While we're just waiting, I was scanning the room to see if I saw too many familiar faces, because if I do, you're probably in the wrong room. This is the intro for Global Alliance, and so we realize it is by now quite a complex and quite a confusing organization at times. So we thought for people who are attending their first meeting or want to know more about the whole of Global Alliance rather than just the piece they've experienced, then this will be a good opportunity for us to give an overview, and I'll do the first part, and then we'll pass over to the specific work stream managers to take you through their details. Okay, so I think looks like the input has slowed. So I don't know, we have another slide? Yeah, so I'm Peter Goodhand, I'm the CEO of the Global Alliance. I have been with it since the very beginning, since before it was a Global Alliance, and it's actually about 7 years ago here in Boston, on the other side of the river, where we set this thing in motion. And over the last 7 years, it's grown from, the staff have grown from me to now probably a dozen people, and the organization has grown to 580 organizations and thousands of volunteers. So I'm going to give you the overview of Global Alliance, why we started, how we are scaled, and then we'll do a deeper dive into each work stream. So, if you were there when David Altshuler gave his opening remarks last night, he and Eric Lander, more than anybody else, got this thing going because they realized with a rapid drop in genomic sequence pricing, it was no longer going to be the privileged few institutes in one or two in each country doing genome research. It was going to be many universities, many hospitals, many healthcare systems, and it wouldn't just be about research genomics, it would be about genomics into healthcare. And so recognizing that if we took the academic approach, it was highly fragmented. Everybody was doing it their own way on their own scale. And so in order for us to be able to get ahead of what could have been potentially really confusing, somebody had to set standards, somebody had to bring the community together, and it couldn't just be the research institutes, it had to be healthcare, it had to be industry. And so that really was the genesis of the Global Alliance. It was never about bigger or better, faster science, it was always about having impact on human healthcare by organizing that scientific community more effectively. Today, I think it's 580 some organizations. Why this slide always defaults to everything is order of one. So it's actually an error, but take it as read. We don't differentiate between those members. So when we have industry at a Global Alliance meeting, typically what we have is industry scientists, industry development engineers, industry standards people, not sales and marketing people. And we tend not to have booths and exhibits because what we need from industry is engagement as equal partners alongside academics. So we want them inside the room, inside the conference, not in a booth. So we do actually treat all sectors equal, but for some reason it defaults. Key milestones, essentially we did all the prep work in late 2012. We came public in 2013. We wrote a white paper that was published in June of that year. So really, Global Alliance went public with a lot of support. So we basically asked people to sign a letter of intent. Are you willing and able to get behind this? And over 200 organizations did say, we will give it our best efforts to work with you on this, even though we don't know what the name is, we don't know where the money's coming from, and we really don't know what you're going to do, but it sounds virtuous, so we will join you from the beginning. By 2014, we got a name, we got more of an organization, we were able to formally launch it at an ASHG meeting in San Diego. And from the beginning, we set up 4 working groups, and it was a great way to get going. But it very much was about enthusiasm and interest and academic style thinking as we went into our data working group, our clinical working group, our regulatory and ethics, and our security. So we got 4 groups, and we pushed hard with a lot of enthusiasm, but not a real sense of what we were doing or what the real potential was or how to stay abreast of the community. So a little bit, there are certain things we did very well, and probably the first and the biggest of those was the framework for the responsible sharing of genomic and health-related data, led by Barth and Noppers and others. That was a fundamental document from the very beginning. We started 3 demonstration projects, BRCA Exchange, the Matchmaker Exchange, and the Beacon. And there were great demonstrations, and still are, of the value and the potential of data sharing. But because we created them at the same time as we did the work groups, they weren't particularly good examples of how to implement and adopt Global Alliance standards because they had to get their data sharing going while we were developing standards at the same time. In 2016, after a couple of chairs, Ewan Burney from EBI took over, and he told us from the beginning, if you want me to be chair, just understand, I will be disruptive and I will push us to change. We've got to be more connected, we've got to be more coherent, we need more discipline. So less of this academic interest in pursuing graph-based genomes and more about what standards does the community need now and what will it need next year, and let's get on and develop those standards. We've called that phrase or phase GA4GH Connect, and you'll see how we do that with more work streams and more independent demonstration or driver projects. So this is our executive team today. Recognize me, yes, by now all of you will probably recognize Ewan. And the other two key leaders are Heidi Ream here from Boston and Catherine North from the Australian Genomic Health Alliance. And that four-person executive committee really makes sure that on a month-to-month basis, the organization is being well led, well run. And then we have a much bigger steering committee, which is our technical approval mechanism for all the standards in the release. And that's closer to 40 people. So when you look at the work output, it goes through a review process and approval of 40 plus people, but the day-to-day of Global Alliance is this group. We got some things we do and some things we don't do. We're very happy to do what we're doing now and convene stakeholders, to catalyze, to be part of that movement to share data and foster innovation. So there are very tactical things we do. And on the other side, what we don't do is own, generate, store data. We don't perform research. We don't interpret genomes. So that's the role of our driver projects. So Global Alliance is very focused on this development of interoperable standards, policies, and frameworks coming through our work streams. But the people who have the use case, who have the data, who do the implementations are our driver projects. The thought, the hope, the opportunity is if instead of just going left to right and taking research knowledge and pushing it into healthcare, if as healthcare starts to adopt more and more genomic sequencing, we can learn from those healthcare genomes, then we think very rapidly we can shift the research budgets instead of generating sequences to doing research on sequences that have been generated. That will mean we've got to get secondary use of healthcare genomes. And that means we're crossing a translational boundary, and those worlds have stayed often apart between research and clinical care, with clinical trials in the middle. So we talk a lot about moving across that continuum, but not just in one way, not just left to right from research to healthcare, but also back again in a learning health system. It means we've got to behave differently. If the old model, when the data sets were not entirely too big and they were research, you could aggregate the data. And you could do in one place, you could do the compute, the analysis of downloaded data, and then send the results to where you need to go. That aggregation of data is still valid in some instances, particularly in things like knowledge bases. You can aggregate knowledge much more easily, make it publicly available. But it's not a good model for dealing with health data. It's got privacy, it's got geo-sovereignty. And so we talk more and more about federated data sharing. Leave the data where it is. It's too big to move anyway. It's got all kinds of concerns. Send the analysis to the data rather than bring the data into one place. So a shift, a new paradigm for data sharing from the idea of data copying into data visiting. That somebody will host their data. They will set the rules of engagement. They will permission you to visit their data. They can track how you behave with that data. If you don't behave well, they won't let you come back. So a big part of being able to deal with healthcare data and very large data sets is think of data visiting, not necessarily data copying or downloading. Some core principles we've had pretty much from the beginning. We've always had an international focus. So even though we work with driver projects that are individual country specific, each one of those that is country specific has said part of their long-term plan is once they've got their own data sharing sorted out to then share internationally. So we've always had that international. We've always thought, but much more recently, about this translational continuum and this bi-directional move, federated. And interoperability for us was never saying we want everybody to do the same thing all the time, but when it comes to interoperability, We want collaboration. We need to all agree on the interfaces and interoperability, but we like to see competition on the implementations. So whether it's commercial competition or academic competition or healthcare, compete on the implementation of these standards, but have the standards in place so that we can achieve interoperability. So this is the big matrix. Actually, if it was the big matrix, then it would have 23 driver projects. But we have 6 technical work streams, and you'll hear about those. And we have 2 foundational work streams. And the first of those is regulatory and ethics, and the second is data security. So those 2 foundational ones come over from the first part of Global Alliance. They cut across everything. But we also took what was 1 data working group and 1 clinical working group, and we divided it into 6 more focused, more deliberate technical work streams, and you'll hear from the managers of those. So the work engine, the output, the delivery mechanism for Global Alliance are these 8 work streams. We have leaders, volunteer leaders, we have staff members. That's our production unit. Our consumers and our people who tell us what we should be working on and implement what we've delivered are the vertical, the driver projects. These are the driver projects. We started originally with 3 in the old model, went to 13 as the next stage, and now to 23. In the last round of driver project expansion, which took place just earlier this year, a big imperative for us was to become more global. It was relatively easy to form an Anglo alliance, much more difficult to form a global alliance. So we pushed very hard in this last round to get places like GEM Japan, to get H3 Africa, and to get more European, more non-English speaking Europe at the table. And we've been helped in that global expansion by some of these are not just country specific, they're either continental wide or they're international by scope. So those are the 23 driver projects. We should add up how many genomes those 23 represent. But their role with us is tell us what we should be working on. We check in with every one of them. Embed some of your people into our work streams if you've got that bandwidth and it's a critical standard for you. And then be prepared, willing and able to implement that standard when it comes out the other end. But we've also got a much bigger global community. And so we have a group that Catherine leads called Partner Engagement, and we might rephrase that into more broadly engagement. But the idea is those 23 who are working with us on the inside are a small fraction, an important fraction, but a small fraction of the broader community of genomic research, data sharing initiatives, and particularly of healthcare. So when we look at it outside Global Alliance, there's about 150 genomic data sharing initiatives globally. When this slide was written, it's probably 160 by now. So what we've asked for those 23 is to be a proxy, be a representative of the 150, because we want the standards to be applicable and to be used by all 150 initiatives, and ultimately, when it's healthcare, by all of healthcare. We don't want to just design for the 23, but we want to use the 23 as our best way of knowing what to design for the whole community. In terms of a product pipeline, we push ourselves harder at the beginning to say, why are we doing it? What's important? Who's going to use it? What's going to be the application? Will it get embedded in a pipeline, or will it create a new file format? So clarify up front, what is it we're developing? Push it through that development cycle. Steering committee approves it, and then we publicize it, and we'll be doing that this afternoon. You'll be hearing all about those most recent updates from Global Alliance. And then once we've got it announced to our community, then find ways to disseminate it. And it's pretty much a different way depending on what the standard is. If it's a file format, it's one way. If it's cloud-based workflow executions, it's a different community who needs to know to implement. So depending on what the standard is, it's a very different way to promote it. At the end of it, we're looking for a learning health system. We're looking for, instead of, now that we digitize health, our ability to learn from healthcare in real time and feed that knowledge back into better genomic knowledge and keep a virtuous cycle of improvement. I've put on that right-hand side, sorry, on the left-hand side, there is a proud tradition of sharing data, genomic from human genome, 1,000 genome, HapMap, ICGC, long 30-year tradition of sharing data in genomic research. We've got no tradition of sharing genomic health data or any other health data. It stays inside a hospital in a city. It might go across a system, but it's a struggle for everybody. So I think as we move, we want to make sure that what we're designing can achieve relevance globally. In healthcare, it can create knowledge, but we know the culture is something we have to change, and the incentives have to be changed for healthcare to become part of this family of data sharing. So with that, I think we'll take questions at the end. So I'm going to pass over to Adrian Thorogood, who runs and has for several years one of those two foundational work streams. Adrian.
Thank you, Peter. So I'm really glad we're starting with the regulatory and ethics discussion as Peter mentioned, as we move to establish international networks, as we move towards more collaboration and data sharing in healthcare, and as we adopt these fancy new federated technologies. Each of these steps is going to be confront institutional policies, institutional ways of working, and also they're going to confront, especially on an international level, different regulations and ethical considerations. So we do commit to focusing on these issues within the Global Alliance. We have a really rich community of over 190 regulatory and ethics active members who attend our calls and join us at meetings. So you may have seen these two wonderful women who are the leads of our regulatory and ethics work stream, Professor Bartha Noppers and Professor Madeline Murta. They're omnipresent at our meetings. They're leading a series of sessions here on ethics. They're helping out with GenoPri. And so if you have questions, please do track them down. Just to give you a quick summary in terms of, if you're interested in engagement, what is it exactly that our regulatory and ethics work stream within the Global Alliance does? As Peter mentioned, it's a foundational work stream. So it's there to sort of support the overall direction of the Global Alliance and to support the technical work streams. If you look at our mission statement, the Global Alliance mission statement, we develop technical standards and policy frames. So it's a key part of our mission is to develop policy frames, which can guide the development on a project or institutional level. It can guide the development of ethical and legal data governance, and hopefully also can also guide the development of regulation that can support the integration of genomics into medicine to support learning health systems. So we have, this is in a sense, it's sort of similar to this technical standards work. We actually develop Global Alliance policies. We put them out into the world. We encourage people to adopt them. The goals of our policy framing activities, including in areas of consent and privacy and security, the first goal is really to promote data sharing, and so we can capture and activate the human right of everyone to benefit from the progress of science. So it's really about driving research faster and ensuring that translates into better healthcare for all. Again, we're part of the reason we develop these policy frames is to we do want to push for data sharing, but we want to do it in a responsible and respectful way. So that's part of why we're here. When we work with the technical work streams is just to constantly be reminding everyone to be, as we design this infrastructure everyone's going to use, are we taking into account how it's going to affect the rights and interests of various stakeholders. And of course, it's not just technology that has to be interoperable. We also do a lot of work thinking about how the governance and policies that organizations adopt, the contracts they adopt, the consent forms that they adopt. Are there issues with those interoperating? Do differences between consent forms make it difficult to integrate data across countries and projects? And so we try and think about the same concept of interoperability, both in terms of our data governance, but also at the level of when you look at different regulations between sectors and countries, thinking about how variations and maybe slight conflicts can affect data sharing and trying to think creatively about how to work around them. So that's our policy framing activity, but we also have a variety of other roles within the Global Alliance. We host a network of ethics liaisons from the various driver projects, so we can kind of keep our finger on the pulse about what issues are you encountering, what new policies have you developed? We often have sort of different groups review each other's policies at final stages to ensure sort of an informal interoperability check, and also learning, just that networking really gives projects a chance to learn from each other. And again, we're a foundational workstream that supports the technical work streams as well. So we are often, some of our members are engaged in the actual technical work stream development. Every single technical work stream product goes through an ethical self-assessment where we ask them a series of questions about how adoption of this tool could potentially affect data privacy, could affect the need for authorizations and contracts and oversight, could affect intellectual property, and potentially could it disadvantage certain groups. So I think it's a great opportunity for the technologists to really engage with the consequences of this rapidly developing technological infrastructure. And finally, we provide some support also just developing the internal governance of the Global Alliance. Right now we're developing a copyright policy to help guide the contributions of software and documentation to the Global Alliance, and also making sure that what the Global Alliance develops, so work products and standards, are accessible to all. So I mentioned so back to the policy framing, Peter mentioned that one of the landmark achievements in the early stage of the Global Alliance was the development of a framework for responsible sharing of genomic and health-related data. Again, this policy framework puts a lot of emphasis on the need to share data, and so I think that's what makes it an important resource, and what makes many of our subsequent policies important resources. They really emphasize the importance of sharing and collaborating, while also identifying when we do share what issues come up. And we base this on human rights, Universal Declaration of Human Rights. Everyone has the right to share in scientific advancement and its benefits. And the reason we did this is because often when we talk about differences in ethics and laws, people say, well, in my country, this is how the rules are like this. And then we often get into disagreements about, which make it hard to work together. But emphasizing human rights, first of all, it has a legal grounding, but also it has a grounding in what matters to everyone. What can we all agree on is important to all of us. And so I think it's a great way of having these discussions on an international level. We've reached out and translated this into 13 languages. We're always looking for new volunteers to expand this list. We have an ethics toolkit. So over the years, we've developed a number of policies. They're not standards, they're not technical, detailed. You must include X, Y, Z in your consent form. They're frames to really, ensure that we can agree roughly on the principles that should guide how we approach things like consent. So we want to promote sharing, but we also want to promote autonomous choice. How do we approach things like security protection? We want strong and standard security across networks, but we also have to have some flexibility to realize that if we have very strict technology-specific rules, those can quickly become incompatible across different institutional contexts and jurisdictions. And all of those are publicly available on our website. Policy doesn't grow on trees. We don't just sit in a room for an hour and write up a policy. So we have a lot of actual kind of community work where we do research, we have discussions, we support empirical research into survey work to better understand stakeholder views. So right now we have work on what do people around the world. We have a wonderful survey with tens of thousands of participants with interactive videos asking people how, their perspectives on how they feel about the sharing of their genomic and health-related data. We have a discussion forum that publishes concise blogs on issues around data protection and how this interacts with international data sharing. And we have a rich discussion around return of individual genomic findings, and which we can find really differs across countries, regulatory contexts, and different healthcare systems. And so it's a really interesting kind of discussion to see, on what areas do we need to agree on in this area, and to what degree can different countries approach the integration of genomic information into their health systems at different speeds. Again, this driver project network is really valuable. We have already have 22 liaisons. I've sort of suggested this is progressively we can achieve more and more engagement with this network. So at the very least, we ask our driver projects to assign an ethics contact, and just having that connection and making sure that those projects are informing our policy development is a valuable first step. Of course, we always ask them to up their contribution, just like we ask all of our driver projects and members to contribute to the technical standardization. We really want to see more and more people from the projects bringing their perspectives to developing international policy. So I'll leave it at there, and happy to answer any questions at the end, and I'll turn it over to my colleague, Melissa.
Well, thank you, Adrian. So I work with the data security team, which is the second foundational work stream, but they also have some of the technical work stream roles as well. So one of their first roles is to create and support security policies. And these are security policies that are both internal to GA4GH. So these are policies that we say, as you're creating deliverables, make sure that your deliverable adheres to these policies to ensure security. And it also has recommendations to the broader security in order to make sure that your genomic data sharing is done in a secure way. They also review standards prior to approval to ensure that they don't introduce clear security risks, but not just as this final point that they would come in and give a yay or nay. They will also work with the work streams and help them improve the security of their work. Finally, they also do create these security-specific technical standards. I want to introduce you to the team. We have the two workstream leads, David Bernick and Jean-Pierre Houbeau, and we have the security review team. These are the people who review the standards and make sure that everything is going to be up to the gold standard of security. And this team works directly with JP at EPFL, and there's Jean-Louis, Juan, and Francesco. They are working on several projects that cross all of these different areas that I previously mentioned. One, they're always updating their security technology infrastructure policy, and I'll talk more about all of these in just a moment. The breach response protocol, which is really being headed up by the Australian Genomics group. And finally, the authentication and authorization infrastructure policy, which they're working on in collaboration with the data use ontology team. The security technology infrastructure is on its 4th version, and this is a policy that is both internal and external. So this helps to create guidelines for creating the secure standards, but also has information for these genomic data sharing groups in order to make sure that their initiatives are secure. So it has suggestions for a set of security and architectural standards and guidelines to implement open and trustworthy federated network. But they recognize that every group is going to have different needs, and so it allows for multiple physical and logistical architectures. And it adheres to a lot of the policies that were just brought up by Adrian, including the GA4GH framework principles and their privacy and security policy. The breach response protocol is really designed to help ensure that GA4GH is protected, as well as all of the members of the genomics data sharing community who use GA4GH policies, and really broader than that, because we are all part of the same genomic data sharing community. So the question really comes here is, let's say that there's a data breach that happens in one of these groups. So the first question that it asks is it related to a GA4GH standard? If so, it becomes absolutely critical to us and to everybody else in the community that it gets reported to GA4GH so that it can be fixed. And so it gives a mechanism to report this securely in a way that does not expose this driver project itself until it's ready to start talking to the rest of the world. But in other situations, even if a data breach that has occurred is not directly related to a GA4GH standard, if it poses real reputational risk to the broader community, it's also important to talk to GA4GH. And so this provides a whole framework in order to manage that. There is the authorization and authentication infrastructure that was created with the data use and researcher IDs team, and I will talk more about how this functions a little bit later when I get to that team. But this is the technological underpinning for this concept of a researcher identity passport, and it is based on OIDC using JWT tokens, access tokens. And it works with the GA4GH passport. And one thing it does is it allows for chains of trust. And that means that if one person has some information that is signed off by one organization, that information will be maintained no matter how these passports and visas are combined. So if you would like to get involved with the data security team, they are working on a number of projects. They're refining the breach response protocol to make sure that it works very well with the broader community. So we want to get input from everybody else, see what the requirements are. What would it take for you to report these breaches? We are working on creating new data security policies, including how to write very secure code. This one focuses very much on the code aspect. And we're always refining and updating the review process for the deliverables because security risks are constantly changing. And so we always want new input to make sure that what we're creating is as secure as possible. I also work with the data use and researcher IDs team. So this, I was just mentioning before about AAI. This is a different work stream, and this one is a fully technical work stream. So it doesn't have any of these foundational aspects. Their goals are two main goals that come together. One of them is to harmonize researcher identities and create a computable researcher identity saying who you are as a researcher, and to create a data use ontology that is also computable, so you can tag data sets. And this team right now is being run by Tami Narunen, and there are two separate subgroups. So these subgroups focus on those two different aspects I was mentioning before. There is the data use ontology group headed up by Jonathan Lawson here at the Broad and Melanie Courteau at EBI. And GA4GH Passports is led by Stephanie Dyke at McGill and Craig Voisin at Google. So the data use ontology version 1 has already been created and approved, and we are just wrapping up everything with the first version of the researcher IDs and bona fide status. I'll talk a little bit more about each of these projects as well. So this is what we see the current issue in accessing data. Right now, if you create a data set and it has data use restrictions, these restrictions are written up in a complex format that has to be interpreted. And if I want to access this data, I need to fill out a written form. I need to send it in to a DAC. They have to determine if who I am and where I work for and what my purposes are happen to match up with these difficult to interpret data use restrictions. And this process can take a very, very long time. And so everything that's created in this team is to help make this process as quick, efficient, and secure as possible. So the data use ontology was the one that has already been approved, and what this does is it creates semantic tags that can be added to data sets. So you can say that it's restricted to general research use or to a very specific disease. You can say that it's only usable by someone in nonprofit situations, and so they're computable. So when you can apply for them, the information is very clear as to what the restrictions are. And so this can accomplish a number of things. One is that the categories are standardized and have clear meanings. It can also allow for data discovery. Let's say you want to find data sets that are restricted to being used in a certain situation. Like I work for a for-profit company. What data sets do I have access to? So instead of having to sift through that kind of information and constantly run up against data sets you can't see. And it can also allow for faster turnaround of data access when you apply, it's clear to see what data sets you can use. Then there's that second aspect, the data passports, which is also being wrapped up right now in the first version. And so this is the upper layer to that AAI specification, which I previously mentioned. And it is your ID, who you are as a researcher, what your organization is, do you have signing official permission to access data? It includes that kind of information. It also includes minimal personally identifiable information in order to help comply with GDPR. And it creates a standard language of claims for evaluation. And if you would like to get involved, this team is working on all sorts of really interesting projects. One of the first is to combine the concepts of the data use ontology with passports. I'm not sure if you would, when you were listening to this, you saw, well, if I say I am from a certain kind of organization and I have these permissions and this is what my research purpose is, if that can be directly matched up with Duo codes, then you can get access instantly. Everything becomes a lot faster and stays just as secure. We also want to expand the roles that are included within passports. Right now, we are using very academic-style roles because there's clear definitions for those. And we want to expand that out to include clinicians and even citizen scientists. We're also working with the regulatory and ethics team on a really interesting project where we want to take Duo codes and turn them into consent forms. So they will have you can match the Duo codes to specific pre-written data use restrictions. So it allows for easily interpretable data use restrictions in the consent forms and can further speed up the data access process. And the last team that I work with is Genomic Knowledge Standards, and this team focuses on variants. Ooh, that covered up half of it, but okay. So it wants to enable the consistent exchange of genomic information. So they want to model variants in a clear way that has consistent identifiers, and they want to be able to match up annotations to these variants. This team is run by Andy Yates and Bob Freemuth, and there's two separate teams underneath them. One focuses on modeling the genetic variants themselves, and the second is the genomic annotation group. So the genetic representation group, the variant representation group is Larry Babb, Alex Wagner, and Reese Hart, and the annotations are run by Matt Brush and Javier Lopez. So the variant representation version 1 is also just being wrapped up and is about to be ready for use, and that focuses on modeling the variants, and we are continuing to work on the annotation group as well. So variant representation specification is trying to resolve the issue where variants can be represented in a number of different ways, and it's hard to be able to tell when you're talking about the same variant. So they want to not only model variants consistently, but also create consistent identifiers with them. So the variant representation specification includes a terminology and information model, and a machine-readable schema in order to represent these variants. It includes conventions that promote the reliable sharing of variants, and these globally unique computed identifiers that I mentioned that map directly to the variants. And in order to make it easy to implement, they have created a Python implementation that is available to everyone. Now, when you represent a variant, the real purpose is to be able to say, why do you care about the variant? Because you want to know what knowledge out there exists about this variant. So you need to be able to model the annotations for the variant. And so these variant annotations that we're creating include a core statement about the variant, but then also includes metadata, include evidence and provenance, and any additional information that can provide context about the information. And if you would like to get involved, one of the big projects we're working on now is creating sets of variants or buckets of variants, where you're trying to group a number of variants together, particularly in the frame of annotations. You can say that there's a number of small different of variants that actually end up causing the same kind of issue. So we want to understand how we can define those, how they can be annotated, and what it actually means when you annotate a full set of variants. We're working on defining haplotypes and genotypes, and particularly in the context of crossing multiple organizations like NCBI and HL7, which have differing views on what these words mean. And the annotation spec is actually getting ready to have a V0 release, and we're looking for driver projects to start implementing that. And with that, I will hand this over to Rishi for large-scale genomics.
Thank you, Melissa. So I'm going to talk about the 3 work streams that I manage, and we're going to start off with a discussion on the large-scale genomics work stream. So if we go back to kind of the core basic things that we do with a genomic data pipeline, we are often starting off with a reference genome that's come from a collection of individuals and then been sequenced and then constructed into this is what we consider as the reference genome for this species. And then individuals are then sequenced. We then take what we call the reads from that, and as Melissa's kind of discussing, one of the most useful things is where does that read indicate this individual differs from our reference genome, and we call those variants. So these reads and variants are kind of like the starting point for much of the genomic analysis that goes on. So the first, one of the first specifications that we have at GA4GH is the format for storing reads, and there's been a text version called SAM, and then a binary version of that called BAM. And now we have CRAM as a very efficient format for storing genomic data in a compressed way. And what this does is take advantage of the fact that much of a reference genome will be the same as the individual's genome, so you can save a lot of space by just storing the places where that differs. This has been implemented in many libraries and tools and is being used to store petabytes of data across the world. So in particular, say HTS-lib and HTS-JDK, which form the basis of SAM tools, and GATK and Picard are some very common standard genomic processing tools. The VCF then specifies the format for a text file used in bioinformatics for storing these gene sequence variations. There is also a binary version of that. There are some limitations with what VCF does, and if you attend the talk, the fire hose session later on today, you'll be hearing about the improvements that are going ahead with the VCF that are being investigated. So as we move, as Peter said at the start of the talk, we're moving to a world where the volume of genomic data is sort of greatly increasing. So we're moving to federated systems, and one of the issues there is how do we move the data around from a data store to the individual wanting to perform research. And we've got to move away from perhaps a system which is so file-based, so these CRAM files and large genomic collections and VCFs can really mount up in size. So htsget provides a way of streaming information to the user. It allows slicing, so if someone's only interested in sort of the first 2 kilobases of chromosome 3, they will only retrieve that data set. They don't have to retrieve a whole file that contains a whole load of extraneous information. And this also makes it adaptable to being placed on distributed systems, on farms and so forth, where each, you might break processing a whole genome into lots of smaller jobs. And this servers standing up htsget are now being set up in many places. One of the issues that we have concerns about is obviously security of data. We there are, to prevent, say, the situation where files are on someone's laptop, it helps if they can be stored encrypted at rest. So Crypt4GH is something that we have just announced, and this is a random access encrypted file container that can be used to store, securely store this large-scale genomic data. So what this means is that the random access allows it to be used in analyses without being a completely decoded file. So if you sent someone a zip file of a CRAM file, for instance, with a password on it, that's kind of distributed in a protected way. But when it reaches the end user, they have to completely decode, unencrypt that entire file. What Crypt4GH does is a container format where it can, the user's key allows them entry into the blocks of the file where they want to retrieve data from for processing. That's just in memory, and so the whole file remains at rest, and it's an extra layer of security for data stores who have received this encrypted data in case they are attacked in any way. There'll be, again, more information about this in the Firehose session. One of the RNA sequencing and RNA-seq data format is also very, very popular, and one of the cases that the future is presenting, in particular by, say, the Human Cell Atlas, where you have large volumes of data and perhaps in a very sparse format, you want to be able to retrieve RNA data at a large scale. So what we have here is a format that allows you to request data, and then it returns it in standard sort of Loom and HDF or HDF5 as you require, but with a standardized format, so that the tools that then process the RNA-seq data know that they're going to get a standard data matrix as described in a specification to work on. To go back to the starting point, though, the first thing I talked about was our reference genome. So we have this in many species have reference genomes. We have our GAAGH for the human. The RefGet API, however, one of the issues we found that in the research community is that different organizations have different names for maybe for the reference genome itself, or some use CHR1, some use one for chromosome naming. So we want to move, if we're going to move to a world where we're processing large volumes of data, we need to make sure that things are reliably can be accessed and used for computational purposes. So the RefGet API enables access to a reference genomic sequences, but it doesn't give this thing a human-based accession or name. It uses a checksum identifier based on the sequence content itself. So the reference sequence is normalized. There's different checksum endpoints on offer. And this is now going to be used in the EGA, and we're looking at setting up mirrors on AWS so we can have distributed bases for the human, for reference genomes to be used across the world. So the second work stream I'm looking after is the cloud work stream, and kind of going back to what we were, again, Peter's talk at the beginning, where we're moving to a federated world. We're moving to a place where we are going to have less and less direct download access to healthcare data. They're going to be behind legal, and also the volume of data means you don't want to be downloading all the files you want to use your analysis on. So these databases will get populated either by projects or clinicians as they collect genomic information. These can then be attached to cloud server environments, and what the cloud workstream is doing is developing a suite of APIs to allow tools to be run on these, the cloud environments that are indicated there. So the first of this is the tools registry service, and this is now version 2. So this is a standard way of exchanging tools and workflows to analyze and read and manipulate the genomic data. So one of the issues that we face is that repositories at the moment have they can be just a list of files or scripts, not obtainable and they have to be hacked together to get them to run on the cloud environment, or they might be attainable through a sort of a custom API. With the TRS API now, you'll be able to retrieve a specified tool and run it on a specified environment that I'll talk about in a moment. So one of the benefits of this is that you can version these tools as well. So in the healthcare sector, one of the things you need to be able to support is being able to accurately recreate what pipeline was run. So by using, again, a checksum computed based on a workflow, you can say definitively this was the workflow that was used to process this data. And the tool repository service is that store. In addition, if you have, say, a health institute where you have like 20 labs, you can make sure that all 20 labs are reusing the same process, not individually making minor modifications. So there's a whole sort of documentation, paper trail kind of thing that TRS, the API, enables. So then talked about how we want to be able to send these workflows that are retrieved from a TRS environment to the clouds, compute clouds to be run, and the workflow execution service API facilitates that. So you can specify your retrieval workflow using the checksum identifier or the common name and so forth, and then send it to the cloud environment to be run. And obviously there'll be this needs to be done in a secure way. So you can take CWL or WIDL, for instance, log into the provide credentials, and then access compute time on these servers. The final piece is still of this process is the data repository service. And so this is a way of, when we send compute off to be run, at the moment, how do you send the data to go with that compute? And so the DRS is a way of naming agnostically the data sets that you wish to be processed. So this allows you to access the data in a standardized way as well. So this is coming to, this is currently in its final stages, so look to that coming on board shortly. So over the next year, the cloud workstream will plan to take these three APIs and start enabling people to set up endpoints with the system across the world. So finally, the last workstream I manage is the discovery workstream. So this is trying to ask a question. We talked about how there's a huge volume of data, and we're moving to a federated system. So if you have a federated system with lots of data sets and databases, how do you know which data set contains what you are interested in? So as a starting point, the Beacon API allows, for instance, you to query a database just to see if it has a variant that you are interested in. Now, there may be, this ties into what Melissa was talking about with access. You may not be allowed initially without, it allows the data holders to expose, give a yes-no response to that question, is this variant in my data set? You then would tie that into the AAI and the passport kind of thing to be then granted access to more information about that variant. So the Beacon API is kind of an interesting way of exposing data inside a data set without giving too much information about what's in there to the public. So in addition to that, we have the case discovery API and the search API in development in this space. But the other side of the discovery workstream is about how do we join all these things that we're talking about, how do we put them together? So you're going to have a system where there are not just, you don't want to help just for find the data sets you're interested in, but you need to know what's inside them, what services and protocols do they support. So we have they are forthcoming again shortly, will be a service registry, and this is a way of, will be a way of listing servers and what they support, and we're, with a service info protocol on a GA4GH server, you can then query that server to know what it holds. And so if you want to search a tool, you can put in a single space, a single search query, and then go across the nodes. You'll find all the TRS endpoints, and it could find that tool for you. You can then hit a data store. It may store the data, say, in VCF, query it with a beacon, then use the htsget protocol to retrieve the VCFs of interest. And then you could, using the service registry again, try and find a list of supported cloud endpoints for running your analysis on. So with that, I'll now hand over to Lindsay for work on the clinical and phenotypic data capture.
Okay, hi, so I'm Lindsay Smith. I manage the clinical and phenotypic data capture workstream. I was just running in from national initiatives, actually. I coordinate that as well. And I'm just going to give you an ever so brief overview of what we're doing in the ClinPheno data stream. Microphone. Yeah, microphone. Oh, sorry. Is that better? Okay. So this is us. So that's me on the left, the workstream manager. And on your right are two workstream leads. We have David Hansen from K0 and Australian Genomics, and Melissa Hendel from Oregon Science and Health University, and the Monarch Initiative. And if you see us around, I really encourage you to come up to us and chat more about what we do. And so what do we do? So we support the clinical adoption of genomics through establishing standard information models, schemas, best practices for use in genomic medicine and research, including the capture and exchange of information between electronic health records and research systems. And so what you'll see here is our three sort of main focus areas right now. So the first one is Phenopackets, which is a schema for exchanging phenotypic information, pedigree representation, which is a structured way of representing pedigree information, and then best practices and terminologies, which is a bit of a newer area that we're exploring right now. And I'm just going to briefly touch over two of these. So Phenopackets is our newly approved standard that's going to be sort of announced at this plenary. A lot of people contributed to this work, but I really want to highlight Peter Robinson and Jules Jacobson, who led the technical development. They unfortunately couldn't be here, but they do have a poster out in the hallway, and I encourage you to go check it out. And so Phenopackets is a standard schema for sharing both high-level and deep phenotypic information. And so the idea behind this is that with genetic information, there's already these standard formats for exchanging it, for example, like VCF, but there wasn't something for phenotype information. So conceptually, you can think of it like a VCF file, but for phenotype information. And so this standardized structure for phenotype data will catalyze integration among distributed sources, such as authors, journals, data repositories, and clinics, when appropriately consented, and accelerate clinical utilization of this data to affect more precise health outcomes. And you're going to learn a lot more about this later this afternoon. And so the other sort of main area we've been looking at is creating a pedigree standard for representing pedigree information. And so earlier this year, we conducted a survey across driver projects and other interested parties about how they're using pedigree data and what sort of challenges they're having. And this was sort of the main takeaway we had. In short, a lot of people are experiencing problems with pedigree information. So, hand-drawn pedigrees, lack of computability, the inability to represent more complex families. And so we've been looking at how we can better represent this data to make it more exchangeable. And this work is being led by Orion Buskey and Grant Wood, who are both here at Plenary as well. And so we just sort of kicked off this work yesterday. So we're really in the first milestone, which is stakeholder engagement. So engaging with the key data producers, creating a like a document of all the difficult family history cases that we might need to represent, and sort of looking at a gap analysis of existing formats and how we might be able to better represent the data. And so again, I encourage you to come chat with us about it, and if you have any use cases or are interested in getting involved. And so what else is next? So for Phenopackets and both Pedigree Standard, definitely ongoing work. So for Phenopackets, we're looking at what should our next release prioritize, what do we need in V2 that might not be in V1. For the Pedigree Standard, again, we're looking at a lot of the stakeholder engagement. So what are the requirements? What sort of things do we need to represent? And then there's a couple of other questions that we're really starting to ask and explore. So how can we help with standardizing clinical and phenotypic information? And what sort of features do we need within our standards to ensure that we can have an interoperable suite of standards? And then from a couple days yesterday and from previous meetings, we're really starting to look at these other questions like how can we represent treatment regimes or drug responsiveness or demographic information? And so this is how you can get more involved with us. So we do meet bi-weekly, fortnightly, whatever, it's a bit up for debate, what you want to call it. So we meet every Wednesday at the times listed there. We also have a GitHub space. Please feel free to check it out and contribute to it. Just GA4GH -CP for ClinPhenome. And we also have a Slack channel. Please feel free to join it. That's all I have.
All right. So we have a few minutes for questions. I also want to introduce Ashley Hobb, who is our operations leader for Global Alliance. So all the stuff that isn't deep within these work streams you just heard about typically comes to Ashley, and probably more than anybody else. She and I are the generalists who don't understand everything we just heard, but we need to understand enough about it that we can make sure the whole thing works together. So Ashley, come up. So just fire away any questions that any of us.
Bring one. So we've got 5 mics over here, one for each of us.
If you can use the mic,
Yeah.
that'd be great.
And yeah.
Can you hear me? Okay, so the scope of this initiative is defined as genomics and health-related data, which is very broad. Are there the boundaries of this defined somewhere and formalized? For example, specific example, what about clinical imaging?
Okay. So
Peter.
So in one way, the boundary is, we understate it. So when we say genomic, we actually mean all of omic, but only that omic-related data. And when we say health, we mean the health data that faces in towards genomics, so those omic data sets. So we wouldn't be talking about clinical imaging, we wouldn't be talking about those things, but it's the health data that is related to omics. Having said that, yeah, okay. So what comes from the omics that come from the genome. But I think where we've said in that, and we're very keen to work with HL7, to work with ISO, because we recognize we don't have the expertise, we don't have the credibility to shape health informatics and health standards, but we need to make sure what they're doing as it faces genomics, omics, is actually interoperable. So we work very closely. There's a session going on for most of the morning about collaboration between HL7, ISO, and Global Alliance. Okay.
Question on how your work relates to the Human Genome Variation Society and their nomenclature recommendations.
So some interesting discussions going on right now. What we try to do is not, if there are established areas, established groups well respected, is not replicate, but again, work very closely with them. And I think as HGVS and Hugo and other groups are starting to say, how do we make sure that we've got sustainability, we can move forward, we can represent this, we need to work closely with them. And I think it's a little bit of a bandwidth issue. So we got to try and say, is there either an urgent need or is something falling apart? Then we'll put a lot of time and energy from both organizations. If it's not, and we're just running smoothly in parallel, then let's not overcomplicate it. But just in the last couple of weeks, the HGVS question has come to me as to how do we make sure that we're working closely with that group?
And the Genomic Knowledge Standards team is aware of HGVS, obviously. I think the main difference is we're focused more on computable ways to manage it instead of having it be human readable, which is more of the HGVS view.
Okay, it's an easy one. That's a good one and an easy one. So from the very beginning, one of the strongest contributors to Global Alliance has been Heidi Ream. And ClinVar/ClinGen is one of those driver project communities. And so some of the things they do, certainly it's because it's genomic knowledge, not individual patient data. That's one of those cases where you can aggregate. And the more you can add quality to it, that knowledge, the better. So we work with them, but many of our standards are not deeply relevant to ClinVar. Yeah. Right. So if it's, yeah, so the question is, how do we work with all the submitters to ClinVar, not just the role of ClinGen as it aligns to improve the functionality? But my understanding is that ClinGen's role is to improve the applicability, the functionality of ClinVar. So when it's deep within that organization, we tend to leave them to do it, to drive it. But to the extent they need interoperability or they need to be using global standards, that's how we would work with ClinVar. And more on that?
So the Genomic Knowledge Standard team is also working with ClinVar as well. One of the things we have started a discussion with them on is how to submit data into ClinVar in consistent manners, and that's an ongoing discussion. It's a big problem, and it's not something that we're able to solve quite quickly, partly just because ClinVar at the moment doesn't have the resources to do it themselves, and so but it is something we're talking about and aware of.
The other thing is that ClinVar was actually the building block for our bracket exchange. So when we went back to those original 3 demonstration projects, the largest BRCA1 and 2 variant database was ClinVar. It was about 7,000 variants, and there were 13,500 BRCA variants known across multiple data sets. Obviously, Myriad knew many more. But what we did is pull those together in this thing called the BRCA exchange, but we used the same expert curation group, Enigma, so that whether you went to ClinVar today or you went to the BRCA exchange, you'll get completely concordant information. It's the same expert group. It's just if you're only concerned about BRCA1 and 2, that's a rapid access through the BRCA exchange. If you're concerned more broadly, ClinVar is clearly the better resource. Okay, probably one more question, I think.
Mine is more general. So when you have potentially a new driver project or a community comes up with something for a proposal, could you describe a little bit about that process? Does GA4GH think about providing seed funding? Is this all in-kind support? How does that process come of a new driver project being identified and coming on board?
It's a great question. I think it's been a challenge for people saying, so what does it mean to be a driver project? And it really means it's the opposite of us giving seed fund to it, because we don't have this. We only have funds, barely enough funds to sustain ourselves. So the role of the driver project is actually driving in to Global Alliance. We took the 3 legacy projects, BRCA, Beacon, and Matchmaker. We added about 8 new in the first go-round, but in the most recent open call, we specified we needed to know that the driver project had got either geographic diversity or human diversity or a clinical expansion, so we were looking for that growth, breadth, but it also had to have the capacity to be able to invest the equivalent of a couple of FTEs into Global Alliance, and it had to have project leadership who were willing to sit on the steering committee and show up to 2 face-to-face steering committee meetings and attend the other 2 that are held by conference call, by Zoom conference call. So it's actually an obligation on a driver project to put in some project leadership into Global Alliance and to put in technical contributors. I would guess that most of them put in 6, 7, 8 individuals for 10 or 15% of their time. So that 2 FTEs is typically not 2 dedicated people. It's half a dozen plus people who represent 2 FTEs. And that's what we really need, because as I said, those 23 driver projects are there to make sure we're doing the right thing, we're doing it well, we can accelerate that, and they're there to implement the standards. So if they haven't got the capacity to implement, it's like they were part of a development process and then they can't be an example. So I think we really need strong, healthy driver projects. But we also said that we're going to settle down with these 23 right now as driver projects, but we've probably got half a dozen that I can think of, including Seneca is probably the European cohort one. It's probably the best example. very significant genomic data sharing initiatives using Global Alliance standards. They're not a driver project, but they're a collaborating project, and they're just, in some ways, they're almost as important to us because they're part of that expansion beyond our narrow community. Thoughts, driver project? Okay, thank you very much. Please enjoy the next 2 days. I hope from Ewan's remarks and from mine, you understand it's a very inclusive, a very welcoming community. We know it can be confusing. We know it can get very geeky, or it can get very ethical and regulatory. So all of it won't appeal to all people. But please find a piece that's relevant to you and engage as much as you possibly can. Thank you.
And also feel free to reach out to all of us up here.